Good morning, everyone. My name is Amit Kumar Singh, and welcome to my class on permutation and combination. I'll come up with couple of videos, and I'll try to cover the maximum portions on the topic called permutation and combination. Permutation combination is one of the most important and considered as one of the very difficult topic when we talk about quantitative aptitude exam point of view. When we talk about permutation combination, it is advanced form of counting. So the application of numbers, what we have already discussed, and we are trying to understand that application of numbers. And certain time when we end up with a complicated scenario, then the best useful tool for us to work on the that calculation would be the application of permutation and combination. While working on permutation and combination, the most powerful uh, tool which help us in working on permutation combination is the concept of factorial. So factorial plays very important role when we talk about the calculation of permutation combination. When we talk about factorial, we represent factorial with this symbol. And normally, when I talk about factorial, generally the factorial is represented as n factorial, where you can say n factorial is equal to n into n minus 1 into n minus 2 into n minus 3 into n minus 4. You'll keep doing this calculation till you'll get a value called 1. So this is the general way of representing a calculation in the term of factorial. So if I ask you what is 0 factorial is 1. If I talk what is 1 factorial is 1. What is 2 factorial? 2 factorial is 2 into 1. So then 3 factorial is 3 into 2 into 1. If I ask you what is 4 factorial, that is 4 into 3 into 2 into 1. Then 5 factorial, that is 120. 6 factorial is 6 into 5 factorial, or you can say it is 6 into 5 into 4 factorial, that is 720. If I ask you 7 factorial is 5040. Try to memorize this value. 8 factorial is 40320. As much if you can remember, 9 factorial is 362880, while 10 factorial is 3628800. If I ask you what is 11 factorial, so I don't know the value of 11 factorial. Probably I can say 11 factorial is 11 into 10 factorial. So 10 factorial is 3628800. And if I have to multiply it by 11, then I can use my tool on Vedic maths. So any number multiply with 11. So write down the first digit, then add the digit. 3 plus 6 9, 6 plus 2 8, then 6 plus 2 8, then 8 plus 2 10, then 8 plus 8 16, then 8 plus 0 8, then 0 plus 0 0, and then 0. So probably the answer would be 0086193991680. So that is 11 factorial. So that we can confirm by using calculator. So so if I want to confirm with calculator, so then you will get the same value. So 393991680. So just I thought I know the value till 10 factorial. I thought to do 11 factorial just to do what you say, a kind of revision for the Vedic maths concept. I believe you have seen my videos on Vedic maths. So all these I have discussed. So I have developed around 8 videos on Vedic maths where I've discussed all these concepts all together. I believe you have seen them. Now, going further, when you talk about the concept of factorial, if I can prove that, I can prove that y0 factorial is 1. So that many times that question comes in many exams. So you know that n factorial is n into n minus 1. So probably I can say 1 factorial is 1 into 1 minus 1 is 0 factorial. So you can say 0 factorial is 1 factorial by 1. So by that I can tell 0 factorial is 1. Going further, I believe you know the concept of trailing zeros and all. So basically from 0 factorial to 4 factorial, so the number of trailing zeros means the number end with how many zeros, that is called trailing zero. And that zero you can calculate depending upon how many fives are multiplying with 2. So bit from 0 to 4 factorial, no number end with any zero, so the number trailing zero is here 0. While from 5 factorial to 9 factorial, you have one trailing zero. While from 10 factorial to 14 factorial, you have two trailing zero. From 15 factorial to 19 factorial, you have three trailing zero. While if I talk from 20 factorial to 24 factorial, it have four trailing zero. While from 25 factorial to 29 factorial, it has six trailing zero. So in order to calculate the number of zeros, number of trailing zeros, and n factorial end with how many zero? Trailing zero means like 8 factorial is 40320. So the trailing zero means I'm talking about this zero. So in order to count this zero, you need to figure out how many 5 can multiply with 2. And you know that after every alternate digit, there is a 2. So when you write in the term of n factorial, after every alternate digit 2 will come, because all even, odd, even, odd. So even numbers ending with 2 only. So or even numbers having, definitely they are the multiple of 2. So so here what is important that you count that how many fives are there in that number. So you understand 8 factorial have only one 5. So that's why it has 10. While if I talk about 26 factorial, so 26 factorial is 26 into 25 into 24 into 23 till it goes till 1. So here the when you talk about 5, the 5 you will get at 25, you will get 5 at 20, then you will get 5 at 15, then you will get 5 at 5. So here the number of 5 is 2, here the number of 5 is 1, here the number of 5 is 1, here the number of 5 is 1. So uh, if you count the number of 5, the number of 5 what you can have, so I missed 10. So if you count the number of 5, if you count the number of 5, so with that you can get the number of zeros. The shortcut way, to do this calculation, is to divide the n factorial, whatever is your n factorial, divide that n by 5. Whatever the quotient you get, again divide that quotient by 5. Whatever the quotient you get, again divide the quotient by 5. Then add all the quotients to get the number of 0. If I ask you that 100, so suppose something like that, 103 factorial end with how many zeros? End with how many zeros? Suppose if I ask you this question, so if this is a number, end with how many zeros? So what is the number? Three zeros are there, 103, and then 3. This number end with how many zeros? So divide this number by 5. So you'll get 2000. So you'll get 2000. So once you get this 2000, again divide the 2000 by 5. So what quotient you will get? 400. Again divide 400 by 5. What quotient you will get? 80. Again divide 80 by 5. What quotient you will get? 16. Again divide 16 by 5. What quotient you will get? 3. Now again divide 3 by 5. What quotient you will get? 0. So it ends with how many zeros? So to count that, to count the number of zeros, add these quotients: 2000 plus 400 plus 80 plus 16 plus 3. Do this calculation. So this you get 2400, 2480. This is 2480, 2480. Then this is 96. Now this is 96, 99. So this is 24. This is 24. This is 24. Then 96. So you will get these many zero. So so you will get these many zero. This number end with this many zero. Very simple calculation. So basically, whenever you talk about a number of zeros, basically whenever you talk about number of zeros, what is important for you is to determine how many 5s are multiplying with 2. So you basically you have to determine how many 5s are multiplying with 2. So how many 5s can multiply with 2? So that will give you the number of zeros. So if you either manually you can count them, but whenever whenever the question is something like this, they here manually counting the number of 5 is not a easy homework. So under this scenario, what is important for you is to apply these kind of shortcut techniques. So here the number of 0 would be 2000 plus 400 plus 80 plus 16 plus 3. So if I do this calculation, I'll get the number 0 as 2499. So 2499 will give me the number of zeros. Fine. So I hope you understood this. Now with this you can count the number of trailing zeros. If you want to calculate this value, like 8 factorial is 40320. So if I ask you this, what is the if I ask you what is the last non-zero digit, what is the last non-zero digit in n factorial, or suppose 8 factorial, then the formula what used to count, the formula what used to follow the formula to count the last non-zero digit of 8 factorial, that last non-zero digit is 2. So if you want to calculate that value, then the formula for that, if you want to calculate that value, then the formula for that is 2 to the power a into a factorial into b factorial, where you have to express whatever is your number in the form of 5a plus b. So if you express your number in the form of 5a plus b, then you can calculate the last non-zero digit in n factorial. So then if I talk about 8, I can write 8 as 5 into 1 plus 3. So the last non-zero digit of 8 factorial. So this is the formula. So in this formula, this is your a, this is your a, and this is your b. So if you calculate this, you'll get this. You'll get the last non-zero digit. So this is very simple problem I have taken. I can even ask you the last non-zero digit of 4000 factorial also. So that would be the cumbersome exercise. This is just a demo application I've shown you. Already I explained all this thing in my video while finding the last non-zero digit and last two non-zero digit of n factorial. Please watch my video on finding the last non-zero digit and last two non-zero digit. I can even calculate mathematically this value. So even I can calculate mathematically this value. So for in order to do that, you have to watch my video on you can search my video on the playlist that is about finding the last non-zero digit and last two non-zero digit of n factorial. Please go through that to understand this. And also I have developed video on reminder theorem, where I talked about finding the unit digit and last two digit of x to the power n. All that you can go through. So that will develop a basic foundation of yourself on the concept of numbers. So I believe you have understood the concept of factorial. Factorial concepts are very important, and that help us to many times that help us to solve the problem on numbers also. Like in case, like suppose if I ask you, in case if I ask you this question, that suppose I have to distribute, suppose if I ask you, suppose I have to distribute, suppose I have to distribute 10 mangoes, suppose I have to distribute 10 mangoes to three children. Suppose I have to distribute 10 mangoes to three children. So in how many ways can I do that? If I ask you, in how many ways, in how many ways, in how many ways can I do this? Can I do this? Suppose if I ask you this question, that I have to distribute 10 mangoes to three children. So in how many ways can I do this? So you can solve this question. So in order to solve this question, you can apply you can develop cases, and you can, with cases, you try to find out the possible solution for that. So like possibly suppose those three children are x1, x2 and x3. So mathematically I can write like this, to find the solution of that. So mathematically I can ask you, find the non-negative solution of this equation. Mathematically I can ask you, find the non-negative solution of this equation. So this is a question on numbers, and this question you can do very fast if you are clear with the concept on permutation and combination. Otherwise, you'll waste your time solving this question. So the answer for this question is like this is the answer for this question. If you do through permutation combination, this is nothing but it is a distribution of n identical object. So n identical objects into r distinct places, into r distinct places. So this is actually the question of distribution of identical to distinct. Those who are good with the concept of permutation combination, they know this logic very well. Imagine if you solve it through this question, if you try to solve it by the application of numbers, then it would be very cumbersome exercise for you to do. Otherwise, if you're good with the concept of permutation combination, you can solve this question very easily. So if I ask you this question, so you can solve this question very easily. So if you apply the logic of a distribution of n identical object into r identical places, then your formula would be n plus r minus 1 c r minus 1. So here n is 10 and your r is 3. So the number of ways, if you want to find, so your number of ways for that would be 10 plus 3 minus 1 c3 minus 1. So then this would be 12c2. So the value of 12c2 means 66 ways. This is 66 ways. This is your answer. Okay, so this you can do very easily. So no need of following cumbersome exercise of thinking about all the possible cases. So the total number of ways to get this would be 66 ways you can do this. In case if I ask you the same question, so in case if I'm asking you x1 plus x2 plus x3 is equal to 10, and if I ask you tell me the number of non-negative integral solution, non-negative integral solution, if I ask to tell me the number of non-negative integral solution, then you'll give me the answer called 66. This already I just now I told you. Similarly, if I ask you tell me the number of positive integral solution, means positive integral solution means you will not include a zero into that. So if I ask you to tell me the number of positive integral solution, then you can solve this question by using the formula. That formula is n minus 1 c r minus 1. So n is 10. So n is 10 and your r is 3. So then this would be 9c2, and 9c2 is nothing but 36. So now this becomes so easy a work to be done. So you just need to know the formula. If you know the formula, your work would be very easy. If you know the formula, you don't have to waste your time solving complicated way. You can solve the question very easily by applying the direct logic. So there's a direct formula is there. This all comes under the distribution of identical to distinct. Imagine if someone doesn't know this, then he or she will waste their time by doing complicated calculation. I'll show you that. If imagine if you have to do the same question through numbers, that x1 plus x2 plus x3 is equal to 10. So if I ask you the number of non-negative integral solution, number of non-negative integral solution. So if you have to solve this, so how will you solve this? You'll think about the possible cases. So the cases can be 0, 0, 10. So in how many ways can you do this? This is 3 factorial by 2 factorial, means 3 ways. So in how many ways can you distribute 0, 0, 10? 0, 0, 10 means one person you'll give all the 10 mangoes, and other two you will not give any mango to them. So in how many ways can you do? So this 10, 0, 0. So or it can be 0, 10, 0, or it can be 0, 0, 10. I hope you understand this. So first person I'll give 10 mango, other two I'll not give any mango. Second person I'll give 10 mango, other two I'll not give any mango. Third person I'll give 10 mango, other two I'll not give any mango. This is done in 3 ways. So this is nothing but, so you can understand how this concept of factorial help you. So you need to understand this. Like suppose my name is Amit. So in how many ways can you arrange the letters of my name? That is 4 factorial. So there are 4 letters are there, AMIT, 4 factorial. If suppose apple, in how many ways can you arrange the letter word apple? That would be 5 factorial by 2 factorial. Because P has came 2 times. That's why that logic I hope you're understanding. So if I give you a word like probability, probability. So probability is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 factorial divide by 11 factorial divide by b came 2 time. So you can write 2 factorial. Then I came 2 time. You can write 2 factorial. I came 2 time. You can write 2 factorial. Then any other letter repeat. So P not R not O not A not. Then you understood. So this so I hope you understood this. So so that the reason when I'm asking you, when I mentioned this 0, 0, 10. So in how many ways this can be done? So you can understand this. You can understand this. So this would be 3 ways. So I hope you understood 0, 0, 10. So this is one of the case. This is one of the case. The other case can be 9, 1, 0. So this is 3 factorial. This would be 6 way. Okay. Then how many other case? Other case can be 8 comma 2 comma 0. So this can be again this is again 3 factorial. This is again 3 factorial, again 6 way. So then any other case, what else I can think? 7 comma 3 comma 0, again 3 factorial, again 6 way. Then 6 comma 4 comma 0, again 3 factorial, 6 way. Like this manually I can think about the cases. Then 5 comma 5 comma 0, this would be 3 factorial by 2 factorial, this would be 3 way. So then including 0, you can see these are cases. Yeah, so now 7 case can be 8 comma 8 comma 1 comma 1, this would be 3 way. So 8 3 factorial by 2 factorial. Then 7 comma 2 comma 1, this would be 6 way. Then this would be then 1 comma 3 comma 6, so this is 6 way. Then a 10th then it can be 1 comma 4 comma 5, then this can be 6 way. Then 2 comma 2 comma 6, so this would be 3 way. So you, like this I have to develop manually all the cases. So like this, then 2 comma 2 comma 6, then 2 comma 3 comma 5, then it is 6 way. And then 14th, then 2 comma 2 comma 4 comma 4, this would be 6 way. Then 15th, this can be 3 comma 4 comma 3 comma 4 comma 3, so this is 3 way. So like this you manually you have to think about all the possible cases. Now if you add them, so now if I add them, so 3 plus 6 9, 9 plus 6 15, 15 plus 6 21, 21 plus 6 27, 30. So these are 30, you can remember 0. So like when I ask you non-negative solution, in that you remember 30 were there. So 30, 33, 33, 39, 33 plus 6, 39, 45, 51, 54, 54, then 60, then 63, then 66. So you can understand 66 way. So the shortcut formula, if you remember, n plus r minus 1 cr minus 1, that no need of doing all this cumbersome exercise. You could have done it very easily with those cases. When I'm asking you only positive solution, means natural number, solution should be natural number, then you need this sum. So if you do this sum, this is 66. If you subtract 30 from that, you will get 36. So that formula for that, I represent n minus 1 c r minus 1. So I hope you understand. So if you start using the concept of numbers, how the process becomes such a cumbersome work, and the same thing can be done so easily by applying the concept of permutation combination. So permutation combination is basically, when we talk about permutation combination, it is basically the advanced form of counting. So the intention of performing this form of counting is to make the calculation easy. So if we are good with the calculation, if we can understand this form of calculation, then whole exercise will become not at all a difficult point to consider. So the whole exercise we can do it very easily. So that is something which we need to understand, how we can process our calculation. So that agenda should, I believe, you should be clear with that agenda. So like suppose if I ask you one question, like if I ask you this question, so what is the number of, if I ask you what is the number of distinct, what is the number of distinct terms, what is the number of distinct terms in the expansion of, in the expansion, if I ask you what is the number of distinct terms in the expansion of a plus b plus c to the power 20. So now this expansion, this you can solve with the application of binomial theorem. This you can solve it with an application of binomial theorem. So if you start using in the form of binomial theorem, altogether the calculation will become very lengthy. Now the same question you can solve it by applying the concept of permutation combination. So basically, when if you apply the concept of permutation combination, you can represent the general, the question in the form of general term, where general term you can write is k into a to the power x into b to the power y into c to the power z, where you need to understand whenever you write them in the exponential form in this term under binomial theorem. So where you need to understand that the sum of x plus y plus z should be equal to 20. So that you need to keep always in your mind. So if you do the expansion of a plus b to the power n, so whatever the value you get with the coefficient, the sum of the powers is always equal to the total power. Now it is again the same logic on the distribution of distinct the value. So this identical value into three distinct places. So again, so the total number of terms, so the number of terms for this will be n plus r minus 1 c r minus 1. Simple. So this is 20 plus 3 minus 1 c3 minus 1. So this become 22c2. So 22c2 is nothing but 21 into 11. 21 into 11 means 231. So the answer is 231. So I hope you can understand this. So the same question which we can do in if you start solving and all under binomial theorem, the altogether this would be very complicated calculation, but the same thing can be done very easily by applying the concept, and you can do it without spending much time and all. So like if you start applying binomial theorem, so in under binomial theorem, in under binomial theorem, if you start writing binomial theorem, so then the calculation will become very complicated, that a plus b to the power n is nc0, a to the power n b to the power 0 plus nc1, a to the power n minus 1, b to the power n nc2, a to the power n minus 2, b to the power 2 plus nc3, a to the power n minus 3 into b to the power 3. So like this you will do till ncn, a to the power 0, b to the power n. So then you can understand altogether, this becomes such a complicated thing to be done, where I believe you should know, point to remember, remember means PTR, point to remember, always remember NC0 plus NC1 plus NC2 plus NC3 till NCN, that should be equal to 2 to the power n. So that you can prove through Pascal triangle and all. So this become altogether a very complicated calculation altogether. This will become such a complicated calculation if you can understand this. So now you need to understand how fast you can do this calculation. So that is something what is important for you to go through. So you need to understand that part. Like imagine if I ask you a plus b to the power 3. So you know a plus b to the power 3, that is a cube plus 3a square b plus b square plus b cube. You see all the forms what you got here. If you do the power sum, if you do, that is always 3. So that you need to understand, like the same way. So when I'll expand this a plus b plus c to the power 20, I'll expand this. So no matter what coefficients and what a b c, that powers and all I'll get, the sum total of the power, that should be equal to 20. So it's like it is like distribution of 20 into 3 distinct places. So in how many ways you can do, that gives you the number of terms in that. So I believe you can easily understand this part. Okay, so this is not at all difficult thing to be done. Now one more concept if I want to discuss on this. So if I ask you find the coefficient, if I ask you find the coefficient of a to the power 4 b square c cube d to the power 5 in the expansion of in the expansion of a plus b plus c plus d to the power 14. If I ask you this, find the coefficient of a to the power 4, b to the power 2, c to the power 3, d to the power 5 in the expansion of this. So you know that you just now I explained about the general term and all. So the general term of this, you can write them in this form: a to the power x into b to the power y into c to the power z into d to the power k. You know that will be equal to 14. You know this very well. Now you need to understand that here the sum of x plus y plus z plus k, that is equal to 14. You need to understand this. The sum of x plus y plus z plus k, that will be equal to 14. And what you need to understand, next part is that when you split the values, as you can see, the power is 14. When you split the values, as you see, the power is 14. So it is like just filling it 14 parts. It's like filling 14 parts. So you can understand, it is like filling 14 part, 1 2 3 4 5 6, like this. You are filling it in 14 parts, and out of that 14 part, you need to understand 4 part you have to take a. So you need to, it's like you're placing, like if you see the sum of this 4 plus 2 plus 3 plus 5, that would be equal to 14. So it's like you are placing in 14 parts where the 4 should be A. The 4 places A should occupy. You need to understand, you want at 4 places A should come. In 2 places the B should come. Then in 3 places C should come, and in 5 places D should come. So in how many ways can you arrange this? So with that you can get the coefficient. So if you want the coefficient, of that value, that is nothing but the total is 14 factorial, because you're putting them in 14 part. Divide by A is 4. A came 4 times, so 4 factorial. B came 2 times, means 2 factorial. C came 3 times, means 3 factorial. D came 5 times, means 5 factorial. So that will give you the answer. So that will be around 520. So you can solve this. So with this you can get the answer. Already I explained you that this concept already. So whenever the repetition happens, already explained you by giving many examples and all. So I hope you can understand this part. Doing this is not at all a difficult thing. So only thing that you should understand, so you need to understand how to work on this. So the idea what I want to tell you. So these kind of question, if you start solving it with the concept of binomial theorem, what we have studied in our 11 12 maths and all, then altogether the whole exercise will become very complicated. But the same can be done very easily by general calculation, and that is what you need to learn. So my intention of discussing right now is to tell you the importance of this topic called permutation and combination. And this, and in order to prove this fact, that permutation combination is the advanced form of counting, and this advanced form of counting will ultimately help you to solve the question in much more easier way. So if you can understand that part, then it will really, then you can easily understand the objective of me discussing this fact with you all. Okay, now like imagine you, I definitely you people would have solved the problem on dices and all. So the that sum on two dices and all. So whenever you talk about dice, and all, if I talk about dice and all, so the total number of cases in the case of dice is 6 to the power n. So if two dice is there, then 36 cases. Three dice is there, 216 cases. Four dice is there, 1296 cases. I believe you have understood the application of dice and all. So we will discuss the application of dice by using the concept on permutation combination in my next session. So this session, I have discussed about the reason why we can correlate the fact that permutation combination is nothing but it is an application of numbers. So that application of numbers, whatever we have learned till now, so that application of number we can use to solve the problems. And that way, when we are solving our problem, we can easily understand how we can do with our calculation, and that way it definitely help us whenever we go with the calculation. So basically, in the form of counting, you need to understand if m activity can be done, if m activities can be done, if m activities can be done in m ways, if m activities can be done, if m activities can be done in m way, if m activities can be done in m way, and n activities, and n activities is done in n activities is done, and n activities is done in n way, and n activities is done in n ways, then number of ways, then the number of ways in which then the number of ways in which either m or n can be done if m and n are disjoint set, they are disjoint set, or they are mutually exclusive activity, or they are mutually exclusive activities, or if they are mutually exclusive activities is m plus n way. So you have to understand this part, that a certain time, certain activities, they cannot be done together. Like suppose if I have 4 shirts and 5 t-shirts, so in how many ways can I wear them? So I'll wear them in 9 ways. I cannot wear shirt and t-shirt together. So you need to understand wearing shirt and wearing t-shirt simultaneously. It cannot happen. So they are called as mutually exclusive activity. So similarly, if I talk about if two activities can be done together, so the number of ways in which uh, m and n can be done together together is m into n ways. So m into n ways. So suppose if I have 4 shirts and 5 pants, so in how many ways can I wear them? So I can wear them in 20 ways. So because you understand, shirt one, pant one, shirt one, pant two, shirt one, pant three, shirt one, pant four, shirt one, pant five, shirt two, pant one, shirt two, pant two, shirt two, pant three, shirt two, pant four, shirt two, pant five, shirt three, pant 1, shirt 3, pant 2, shirt 3, pant 3, shirt 4, shirt 3, pant 4, shirt 3, pant 5, shirt 4, pant 1, shirt 2, shirt 1, shirt 5, pant 2, shirt 5, pant 3, shirt 5, pant 4, shirt 5, pant 5. If you add them, you will get 20 ways. So means so the number of ways, because I can wear shirt and pants in different combinations. So they can be done together. So then it can be done in multiplication way. So you need to understand in the advanced form of counting, so the rule of addition, this is addition rule. You need to understand the addition rule, and you need to understand the multiplication rule. So you need to understand these two rules. You need to understand the addition rule, and you need to understand multiplication rule. In order to solve the problem, we need to use them to get the value. So it's very important to understand when to use addition, when to use multiplication and all. It is very important. So if I ask you this question, that uh, how many, if I ask you four digit, how many 4 digit even numbers are, how many 4 digit even numbers can be formed, can be formed, can be formed such that digits cannot repeat, such that digits cannot repeat. If I ask you this question, now if I ask you to solve this question, so you can solve this question, you can try to solve this question. In case if I would have asked, if I ask you 4 digit even number, if I ask you 4 digit even number, if I ask you 4 digit even number where digits can repeat, where digits can repeat, where the digit can repeat, that is nothing but that is 4500. So you will draw 4 line, and a number is an even number if it ends with 0, 2, 4, 6 and 8. So any 5 digit can come here. Those 5 digits are either 0 or 2 or 4 or 6 or 8. So with that, I can get I can get I can get to fill the last of place, unit place, because a number is even number if it ends with 0, 2, 4 or 6 or 8. So any 5 ways, any 5 digit can come. So 1, 3, 5, 7 and all cannot come here. Here how many digit can come? 9 digit can come. 0 cannot come here, because if 0 will come at the first place, then it becomes 3 digit number. Now here how many digit can come? Now here how many digit can come? Here any 10 digit can come. Here any 10 digit can come. So if you do this calculation, you'll get 4500. So that you know very well. But here the question is that the digits cannot repeat. If I ask you this question, that digits cannot repeat. So how will you do this question? Think on this part. Tell me the answer. I'm giving you 2-3 minutes time to solve. Everyone, please try to give me the answer for this question. So in order to solve this question, so what you can do, you can draw 4 lines because you have to put 4-digit numbers. You can draw 4 lines, and now when you talk about 4-digit even number, so a number is even if it ends with 0, 2, 4, 6 or 8. So here how many digit can come? 5-digit can come here. Now here when you talk about this place, when you talk about this place, how many digit can come in this place? If you talk about this place, how many digit can come in this place? How many digit can come here? 9 or 8, because here the digits cannot repeat. So you need to understand that if you have used 0, if 0 is used, if you have used 0, then here 9 digit can come. 9 digits can come. 9 digits can come, because 0 you have used, then except 0, then all the 9 digits can come. But you need to understand that if you have not used 0, if you have not used 0 means if you have used 2, 4 or 6 or 8, then how many digit can come? 8 digit can come. 8 digit can come, because if you have not used 0 means you use either of 2, 4, 6 or 8, then in this place you cannot use 0, and then you cannot use the digit what you have used here. So here then 8 digit can come. So if I ask you then how to solve this question, you need to understand this question you cannot do it together, because here the thing is that the digit cannot repeat. Here the thing is that the digit here the thing is that digit cannot repeat, and at the same time you need to define the position of 0 in order to solve the question. So when the digits can repeat, then doesn't matter, then doesn't matter which digit you use in unit place. In the first place 9 digit will come, except 0, any nine digits can come. But because since you cannot use the digit more than once, so here this question cannot be done like this way. Now in order to do this question, now if you want to do this question, so this question is done in 2 way. You'll develop case. In order to do this question, if this question cannot be done together, so you'll apply addition rule to solve this problem. This is what I wanted to discuss, because it cannot be done together. So here you will draw for 2 cases. So in case one, when 0 at the unit place, when 0 at the unit place. In case 2, when 0 not at unit place, not at the unit place, not at the unit place. So then you can solve this question. So if 0 is at unit place, then this place is fixed. If 0 is at unit place, then this place is fixed. 0 is there. There's no permutation combination there. Here, how many digit can come? 9 digit can come. Okay, except 0, any 9 digit can come. Here, 8 digit can come. Here, 7 digit can come. So these many digit can come here. So this is the total number of years. Here, either 2 or 4 or 6 or 8, any 4 digit can come. Okay, either 2 or 4 or 6 or 8. Here 8 digit can come. 0 and that digit cannot come. Here you use 2 digit, then again 8, then here 7, here 4. So now the answer for this, for the 4 digit even number, 4 digit even number, 4 digit even number, where repetition is not allowed, 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 your answer would be 9 into 8 into 7 plus 8 into 8 into 7 into 4. You can do this calculation. 9 8 is 72, 72 into 7. This is 64 into 28. This is 4 this is 504 plus 64 into 28, 64 into 64 into 28 is 6 2 are 12. Then 48 plus 8, 48, 48 plus 8 is 56. And then this is 32. So this is 1792. So this is 1792. So 1792. So this is 6. This is 9. This is 2296. So the answer for this would be 2296. That will give you the calculation here. So that will give you the value. So what value you can get under this situation. So whatever the situation you will get, you can solve it. And the answer for this, the 4-digit even number where the digits cannot repeat, the answer for that would be 2296, and you will get the answer. So permutation combination, its application is very vast while solving the problem and all, and how much we can solve the question, it can be better for us. Like if I ask you this question, that find the sum of all 3-digit number by using the digit 1 2 3 where the digit cannot repeat. If I'm asking you find the sum of all 3-digit number, if I ask you, so find the sum of all 3-digit number by using 1 2 3 such that the digit cannot repeat. Now imagine if I ask you this question. Now imagine if I ask you this question. Now imagine if I ask you this question, find the sum of all 3-digit number, what you can form by using this digit 1 2 3 such that the digits cannot repeat. So you can develop case to that. To solve this, you can think about the cases, what all cases are possible. You can think about what all cases are possible. You can add them and you can get the answer. This is the one way to get the answer. You can do manually to get this answer. But imagine if I ask you this question like 2 and all, then how will you do? If I ask you find the sum of all 3-digit number by using this digit 1 2 3 4 such that the digit cannot repeat. So by using 1 2 3 4 you have to form a 3-digit number. So then how will you do this? So the answer for that would be 4p3. So means 4p3 means 4 into 3 into 2. So means 24 numbers will be formed. How will you do the sum of those 24 numbers and all? So you can understand then so you understand. So the idea what I want to tell you here, that if you start solving it by the application of numbers and all, then it is very cumbersome exercise to do this. So you can apply the logic on permutation and combination here. If you can apply the logic on permutation and combination here. So if you apply your logic on permutation and combination here, you can do the question very easily. Like the idea here is that you can apply the shortcut formula. So the shortcut formula, how what to do the shortcut formula for that, you do the sum of digits, you do the sum of digit, and then you write 3 times 111, you write the sum of digit, then you write 3 times 111 because you want to make 3-digit number, and then apply the formula called n minus 1 factorial. So then the sum of digit is 6, then 111, and n minus 1 factorial, so 3 minus 1 factorial. So this is nothing but 666 into 3 minus 1 factorial means 2. So 666 into 2, you'll get 1332. So, so you get the answer very easily. This way, if you solve, you can get the answer very easily. So I learn to apply the shortcuts and all. So otherwise, if you solve by mathematical approach on numbers, if you start applying the mathematical approach on numbers, so I'll talk about here. I need to form the digit. So I'll talk about like 3-digit number I need to make. So suppose if I'm talking with the digit 1, so 1 can come here, 1 can come here, 1 can come here. Okay, then how many digit can come here? So either of 2 or 3, any of the 2 digit can come. Here 1 digit can come. So here any of the 2 digit can come, 1 digit can come. Any of the 2 digit can come, 1 digit can come. If you talk about 1, the contribution of the digit 1, here the contribution of digit 1 is 100. Here the contribution of digit 1 is 10. Here the contribution of digit 1 is 1. You can understand this. So then in how many ways are there? What are the number of ways are there to form a number? So how many numbers can come here? Two numbers, 2, 3, 2. So like this. So if you want the value, so the value of this would be 200 plus 20 plus 2, you'll get 222. So like this, you did for the digit 1. So like this, I'll do for digit 2, I'll do for digit 3. So like this, I'll do for digit 2. If I talk about digit 2, the value of digit 2, again 3 places, you need 3-digit number. So digit 2 can come here, it can come here, it can come here. Here any 2 digit can come, here 1 digit can come, here 2 digit can come, 1 digit can come, any 2 digit 1, because remaining 2 digit. So then I can talk about their contribution. So what is the digit 2 contribution? So imagine if digit 2 comes, if digit 2 comes in 100 place, then its contribution is 200. Here this is 20, here this is 2. You can understand. Now the number of ways you can understand remaining digit. So they can come in two ways. So you can find it value. So there here in two ways the digit can come. This is 400, this is 40, this is 4. So its contribution would be 444. Similarly, the contribution of digit 3 would be 666. So then you can find the total sum. So the total value would be nothing but 222 plus 444 plus 666. So if you do the sum 12 carry, then 12, 13, 1 carry, 13. So you'll get this value called 1332. So you can do this cumbersome work like this. You can do this cumbersome work like this, or you can apply the shortcut formula. If you apply shortcut formula, your work will be very easy here. Like question number 2, you sum of digit 1 plus 2 plus 3 plus 4. Then you want 3-digit number, write 111, and then the formula what you need to use here. So here, if you understand here, the formula what I told you, that 1 plus 2 plus 3, then I told you write 3-digit number 111, and then I told you n minus 1 factorial. You need to understand n plus 1 n minus 1 factorial is nothing but n minus 1 p n minus 1. I hope you understand this. So then here what you need to understand, general formula is n minus 1 p r minus 1. This is the general formula. So n is the total number. So n is basically 4 digit what is given, and r is basically the three places what you need to put. This is 10 into 111 into 3p2. So this is 1110 3p2 6. So you'll get 6660. So in brief, I have explained all this calculation. This is so just few easy problem I've done. So you can see question number 3, question number 4, question number 5, like this. Around 6 questions are there. So around 6 questions are there. In order to explain 6 questions, I have made a 2-hour video. Just to explain 6 questions, I have made a 2-hour video on summation of digits in permutation and combination. So that is there in my playlist. You can search for that video and understand this concept in much more better way. So it's not so easy concept. This I've done very easily. So this I've done very easily, but you can understand this in much more detailed way, logically, mathematically, and all. So there's a lot of three methods I explained to do these kind of question. So I hope you can understand. I believe you'll definitely will go through my videos in YouTube, which is there in my playlist, and you'll develop much more better understanding about how to work on the calculation and all. So then if I talk about this question, you can see this question number 24, very common question. So this I can solve it like I can write 1 as 2 minus 1 plus 2 factorial. 2 I can write as 3 minus 1. Then 3 I can write as 4 minus 1. Then 4 I can write as 5 minus 1. Similarly, I can write as n plus 1 minus 1. So this, if I open the bracket, this would be 2 into 1 factorial minus 1 factorial. Would be 3 into 2 factorial minus 2 factorial. This would be 4 into 3 factorial minus 3 factorial. This is 5 into 4 factorial minus 4 factorial. Like this is n plus 1 into n factorial minus n factorial. So 2 into 1 factorial is 2 factorial minus 1 factorial plus 3 into 2 factorial is 3 factorial minus 2 factorial. 4 plus 4 into 3 factorial is 4 factorial. This is 3 factorial. This is 5 factorial minus 4 factorial. Like this is n plus 1 factorial minus n factorial. I hope you can understand this concept. Now what you can do, if you notice this 2 factorial get cancelled. So then 3 factorial get cancelled, 4 factorial get cancelled. Similarly, if you understand this, so the in this in further term, the 2 factorial get cancelled, means upcoming term. So you have to understand this will remain like this. And if you see 1 factorial will remain like this. 1 factorial will get cancelled from the previous term. You can see there from 2 factorial get cancelled from the previous term. That's why n factorial get cancelled. So the answer for this is n plus 1 factorial minus 1. That is that 1 factorial what left. That is the answer for this. So I hope you understood this. So you can do this question very easily like that. Now everyone, you can see this question number. You can see this question number 3. Try both question number 3 and question number 4, everyone. Try this question number 3 and question number 4, everyone. Everyone read this question and think how will you do this kind of question. So the easy way of doing this kind of question, how many three-digit numbers are there such that at least one of the digit is 6? So easy way is that how many three-digit numbers are there? Total three-digit number is 900. That you understand three places. Here except 0, any 9 digit can come. Here 10 digit, 10 digits. And at least one of the digit is 9. At least one of the digit is 6. At least one digit is 6. So whenever you get these kind of question, at least means total minus none. Means total minus none of the digit is 6. Total minus none of the digit is 6. So total is 900 minus none of the digit is 6. Means three-digit number, none of the place the 6 should come. So for that, you can do it very easily. So in here, how many digit can come? 8 digit can come, 0 cannot come, and 6 cannot come. Here, how many digit can come? 9, except 6, any digit can come. Here, 9, except 6, any digit can come. So this would be 900 minus 81 8 81 8 648. 81 8 648. 900 minus 648. The answer for this is 252. The answer for this is 252. So answer for this is 252. So this way you can do this question very easily. Otherwise, if you want detailed explanation for this, that also we can do. So okay, leave it. So one of the digit is 6, three-digit number, three-digit number, three-digit number, such that one of at least one of the digit is 6, such that at least one of the digit is 6, such that at least one of the digit is 6. So you can do it very easily. At least one of the digit is 6 means one digit is 6, one digit is 6, one digit is 6, or two digit is 6, or two digit is 6, and all the places, all the digit is 6. At least one of the digit 6 means 6 is coming only once, 6 is coming twice, and 6 is coming thrice. And three cases can you develop? I think you can understand this. So here how many digit can come? Except 6, any 9 digit can come, any 9 digit can come. Here how many here 8 can come, means 0 will not come and 6 will not come. Here 9 digit can come, here 8 digit will come, here 9 digit will come. So this is 81, this is 72, 72. This is 5, and 14 plus 8, 22, 225. And here 9 digit can come, 9 digit can come, 8 digit can come. Okay. So here 18 plus 8, 18 plus 8 is how much? 26. 18 plus 8, 26. Here one number. So how many numbers are there? 225 plus 27. You can do, you will get 252. Fine. I hope you understood this. So going further, if I ask you this question, that in how many numbers of time will the digit 7 be written when listing the digit from 1 to 10,000? So 1 minute. Let me copy this question. Leave it. So first, how many number of time? How many number of time? Number of times will the digit 7 will the digit 7 will come from 1 to 10,000. So can I do from 1 to 1000 first? Very important. This came in last year UPSC exam, General Studies paper 2. So the answer for 1 to 1000 is 300. 1 to 100, the answer is 20. 1 to 100, the digit, any digit will come 20 times. from 1 to 1000 any digit will come 300 times, and 1 to 10,000 any digit will come 4000 times. You can remember this. So here doesn't matter which digit you are talking about. So here I ask you digit 7. You can do any digit. You can use digit 2, digit 4, digit 8. All that doesn't matter. So you can use any digit to get the answer. In any case, all means same thing. Okay, so let me do for 1000 first, and then I'll do for 10,000. Okay, let me do some easy problem first. So for this question, when I talk about this question from 1 to 1000, so you understand that maximum 3 places the digit 7 can come. So here you can develop 3 cases. Case 1, when 7 came once. When 7 came once. Digit 7 came once. This is case 1. So digit 7 came once. 7 digit 7 came once. Case 2, when 7 came thrice. When 7 came twice. Case 2, when digit 7. Case 2, when digit 7 came twice. So case 3, when the digit 7 came thrice. So case 1, when the digit 7 came twice. Once. So here how many digit can come? 9 digit can come. 9 digit. Here 9 digit. 9 digit. Here 9 digit. Here 9 digit. This is 81, 81, 81. This is 243. So when digit 7 came once, means how many times this happened? This happened 243 times. Okay, so now many people will be confused here. Many people were thinking, why sir root 9 is just 8? So you have to understand that number can be 2 digit also not a problem. No? If the number is 1 digit also not a problem. Here imagine both places 0 only come. Imagine here both places 0 come. Then also not a problem, because I have to count from 1 to 1000. Means I need to count 1 digit number also, 2 digit number also, and 3 digit number also. I hope you can understand. Here so they're not asking me 2 digit or 3 digit. So they're asking for 1 to 1000. Same way here 9 digit can come. Here 9 digit can come. Here 9 digit can come. 999. So 999 27. In this 27 cases, the digit 7 came twice. So I don't have to count the number. I have to count how many times you use the digit 7. So you use the digit 7 54 times. Okay. Then third case when digit 7 came thrice. Third case when the 7 came thrice. When 7 came thrice. Here that is only one case. And here how many times you use the digit 7? You use the digit 7 3 times. So then you need to count these all 3 cases. You need to do the sum of 243 plus 54 plus 3. The sum if you do, you'll get 300. Now if I ask you from 1 to 10,000, how many times the digit 7 came? So 1 to 10,000, how many times digit 7 came? How many times digit 7 came? From 1 to 10,000, how many times the digit 7 came? From 1 to 10,000, how many times the digit 7 came? Again, here you will develop 4 cases. Case 1, when digit 7 came once. When digit 7 came once. This is first case. Case 2, when digit 7 came twice. When digit 7 came twice. Case 2, when digit 7 came twice. Case 3, when digit 7 came thrice. Case 3, when digit 7 came thrice. Then case 4, when digit 7 came 4 times. When digit 7 came 4 times. So these are the 4 cases we need to develop. These are the 4 cases we need to develop. So case 1, so I'll draw 4 line, draw 4 line, I'll draw 4 line, 7, 7, 7, 7. Okay, so here how many digit can come? Here how many digit can come? 9 digit, 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 9 digit. So this is 729, 729, 729, 729. So you can do this calculation. So the total number of ways this would be 729 fours are 9 fours are 36, 3 carry, 11, 1 carry, 2916. Okay, this is case 1. Case 2, when digit 7 came twice. Case 2, when digit 7 came twice. Case 2, when digit 7 came twice. So for that, this is 4C2. Then 6 cases will be developed. 6 cases will be developed. 6 cases will be developed. 1, 2, 3, 4, 5, 6. So here any 9 digit can come, and here any 9 digit can come. You can understand, no? This is 81. So 81 will be 6 times. Understand that 81 will be 6 times. 6 cases. In every case, the digit 7 came twice. So here, how many times digit 7 came? Means 12 into 81. So 12 and 96. That will get 972. Okay, and then digit 7 came thrice. So when digit 7 came thrice, when digit 7 came thrice, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, then 7, 7, 7. So 4C3 means 4 cases. So here any 9 digit, any 9 digit, any 9 digit, any 9 digit. So this total number of ways would be, total number of ways is 9 into 4 into 3. Means all the 3. In every case the digit 7 came thrice. So this is 108. And then the last, the digit 7 came 4. So that is only one case, 4C4. Here the digit 7 came 4 times. So then total number of time the digit 7 came, total number of time digit 7 came is 2916 plus 972 plus 108 plus 4. This is 112 plus 972. This is 4. This is 8. This is 1084. 1084. If you do the sum, the answer is 4000. So you can remember this very important thing. So from 1 to 1000, if I'm asking you, then the answer is 300. From 1 to 10,000, if I'm asking you, then your answer is 4000. So I hope you have understood this much. This much we'll do for this first session, and in next session we'll continue our discussion. So basically, right now I'm developing a kind of what you say a environment for understanding the concept on permutation and combination, which we use for solving the problems. So you need to understand these concepts, and these concepts ultimately help us to go through the problems on permutation and combination. So I hope you have enjoyed my session with that intention that you like what all I have done till now. It's time to say goodbye to all of you. So thank you everyone. Thank you for your time and patience. I hope you really learned something from this session. Thank you, everyone. God bless you. Bye.